In the last video, we did a review of exponents. Now we're going to take a look at the properties of logarithms. The reason why we're reviewing this next is because exponents and logarithms are inverses of one another. And we've already discussed about what it means to be an inverse in your 4.2 notes. Inverses are opposites of one another, or they undo each other. So you're actually going to notice a lot of similarities between the properties of exponents and the properties of logarithms. We're going to start off with a reminder of what happens when we multiply two exponents that have the same base. So when we multiply, we can add its exponents. For example, if I have x squared times x cubed, I would add the exponents, so x to the 2 plus 3, and that would give me x to the 5th power. When I take a look at the property of logarithms, it says that if we have the log base b of m times n, so two different things being multiplied together, we can add the log of m to the log of n. So once again, when we multiply, we add. Just like how when we multiplied by the same base here, we added the exponents. And it works in both ways. If I add two logarithms that have the same base, I can condense it by multiplying m and n together. So if we take a look at part A, I have log base 6 of 4 plus log base 6 of 9. They have the same base of the logarithm, and we are adding them together. So since we are adding, and they have the same base, I can condense it and multiply 4 and 9 together. So I'm just going to rewrite it like this. 4 times 9. That's not our final answer. We do need to clean that up. So I have log base 6 of 4 times 9 is 36. We still aren't done though. Remember, you've learned how to evaluate logarithms already. We can use the circle trick to determine, okay, well, 6 to what power would give me 36? So again, 6 to what power would give me 36? The answer is 2. Part B. I have log base 5 of 50 plus log base 5 of 62.5. So because we are adding logarithms that have the same base, we can condense it by multiplying. So I have log base 5 of 50 times 62.5. So if you multiply 50 times 62.5 in your calculator, let's see what that is, 50 times 62.5, you get 3,125. If we can evaluate it, we'd want to. So we need to ask ourselves, 5 to what power would give me 3,125? It's okay if you don't know that right off the bat. We can start plugging stuff in. So if you're like, okay, 5 to what power? Let's just start guessing. So if you're like, what's 5 cubed? That's 125, so too small. Let's go a little higher and say 5 to the 4th power. That's closer, it's 625. Let's do 5 to the 5th power. 3,125. So when you ask yourself 5 to what power gives you 3,125, the answer is 5. All right. The quotient property we saw with exponents. Remember, if we have the same base and we're dividing, we can subtract the exponents. So if I have, let's say, x squared over x cubed, we would subtract those exponents. So 2 minus 3 gives me x to the negative 1. I cannot leave my answer like that. Remember, we can't leave negative exponents, so instead I have to take care of it. When we have a negative exponent, keep in mind you need to move it from the numerator to the denominator or the denominator to the numerator. So this becomes 1 over x to the first power, or just 1 over x. For properties of logarithms, the quotient property, if we're dividing, we subtract. And it also works in the other direction. If we're subtracting two logarithms, we can condense it by dividing the first logarithm by the second. Okay, so it's going to be m over n. We can't go the opposite direction. When I look at part A, they are both a log base 5. So I would have log base 5, and I'm going to condense it by doing 100 divided by 4 because it's subtraction. So 100 divided by 4. 100 divided by 4 is 25. So really this is log base 5 of 25. If you ask yourself 5 to what power gives you 25, the answer is 2 because 5 squared is 25. Part B. We have a log of 5.4 minus a log of 0.054. Remember, if they don't specifically tell you what the base is, we can assume that this is a common logarithm. A common log is a log base 10. So keep that in mind. I have a log. If you want to write the 10, go for it. You don't have to. But I have the logarithm of 5.4 divided by 0.054. If you were to plug that into your calculator, you would see that you get log, base 10 if you want to put it there, of 100. So if I ask myself 10 to what power gives me 100, the answer is 2 because 10 squared is 100. Next, we referred to this as the power to a power with our review of exponents. So when we have a power to a power, we multiply them together. For logarithms, when we have something raised to a power, we're going to take that exponent and move it out front. So it becomes the exponent times log base b of m. So when I look here, I have 32 to the 6th power. I'm going to take that 6 and move it in front. So 6 of log base 2, 32. It is 6 times log base 2 of 32. So I actually can evaluate what this is. If I ask myself 2 to what power gives me 32, the answer is 5. Remember, if you don't know that right away, you can just start plugging stuff in. So I can check myself 2 to the power of 5, see how I get 32? So x is 5, meaning this is 6 times 5. I can simplify that further. 6 times 5 is 30, so 30 is my answer. I just realized I forgot to write the example, but I talked about it. Remember, power to a power was something like this for exponents. We would then multiply that 2 and 3 together. So that's x to the 6th power. Okay, let's take a look at part B. Here I have log base 7 of 49 cubed. That exponent of 3 needs to be brought out front. So I have 3 times log base 7 of 49. We need to move that exponent before we can actually evaluate this. So log base 7 of 49. 7 to what power will give me 49? Well, 7 squared gives you 49. So this is really 3 times 2, or 6. Okay? Now we have what's referred to as the inverse property, and once again you did see it before when we were talking about inverses. So remember, logarithms and exponents are inverses of one another. I mentioned that in the beginning of this video. So should you have an exponent raised to a log, they would cancel each other out and you're just going to be left with that k. For example, if I have 3 as my base, and log base 3 of k, since the 3 of the exponent and the 3 is the base of the logarithm, so since those are the same, they cancel each other out. They must be the same, so 3 and 3. I'm just going to be left with the k. Here, if I have log base b of b to the power of k, I'm just going to get k once again. So you can see when we have an exponent raised to a log with the same base, they cancel. When I have a log of an exponent and they have the same base, they cancel as well, leaving us with just k. And I'll show you why in the notes here. I have log base 3 of 81. Nothing cancels here, right? Because 3 and 81 are different bases. What I can do though is I can rewrite it. I know if I want log base 3 of 3 to some power, I just need to ask myself 3 to what power gives me 81? The answer to that is 4. Now, if you know this rule, you could recognize, hey, they have the same base, they cancel out, the answer is just 4. I'm going to show you why that works. If I have log base 3 of 3 to the 4th power, I know using the power property from above that I can take that 4 and bring it out front. So I have 4 log base 3 of 3. Remember, you saw a rule earlier in our notes that log base b of b is always 1. That's because b to the first power is going to give you b. Anything raised to the first power just gives you itself. So 3 to the first power gives me 3, meaning really this is 4 times 1, or just 4. This is a shorter method, just recognizing, hey, they undo each other, I'm just left with 4. You are welcome to use power property in this rule to get your answer if you like. I'm just providing you with an alternative using inverses. All right, here I see that I have 5 raised to the log base 5 of 10. If you want to use inverse property, you can recognize, hey, there's a base of 5 for the exponent, there's a base of 5 for the logarithm, so they cancel each other out, and I'm just left with that 10. 10 is the answer.